So this is question number 50 of GATE 2017 Metallurgical Engineering. At low temperature, two parallel edge dislocations lying on a parallel slip planes are shown in different configuration below. The configuration are mentioned here is like P, Q, R, S. Four different types of configurations are mentioned here, and for all these configuration we have to decide whether they will repel, attract, or they will be in the equilibrium, right? So to know more about the uh, forces between two dislocations like attraction or repulsion, you can refer lecture number 22 on forces between dislocations from the course Defects in Materials by Professor M. Sundaraman from IIT Madras. So before solving this, let's first understand some basics which is related to the forces between dislocations, right? So forces between dislocation, right? So let's say like there can be different cases. For example, let's say we have a edge dislocation of the same sign, like we have two edge dislocation of same sign and they are lying on the same slip plane. So in that case, what will be the forces? Or let's say they are of opposite sign and they are lying on the same slip plane, then what will be the scenario? So there can be some different cases. So let's say the first case is like dislocation of opposite sign, dislocation of opposite sign on the same slip plane. So for example, this is our slip plane and here we have one dislocation, and on the same slip plane here we have another dislocation. So in that case, what will happen? So uh, dislocation of opposite sign on the same slip plane will attract each other, right? Will attract each other and try to annihilate, and try to annihilate, right? So here we have a, like the symbol what signifies this shows the extra half plane, right? So above the slip plane we have extra half plane due to this dislocation, and on the same slip plane below this slip plane we have an extra half plane. So when this dislocation get attracted, so what will happen? Above extra half plane and below also one extra half plane, so it will make a they will basically annihilate each other and it will form a perfect three-dimensional structure, right? So they will attract each other and they will annihilate each other, right? So in this case, in another case, let's say we have dislocation of likes, same sign, dislocation of the like sign on the same slip plane. Then in that case, for example, this is our slip plane and this is our first dislocation, and on the same slip plane this is our second dislocation. So in that case, what will happen? The dislocation, these two, there will be a repulsive force between these dislocations. So dislocation of the like signs on the same slip plane will repel each other, right? So these are the two cases if we talk about the same slip plane, right? So in a first case they will attract each other, and in a second case they will repel each other, right? So there can be another case like, so the third case if we think is let's say we have a like unlike dislocations. When we have unlike dislocations and they are on the closely spaced slip planes, and they are on closely spaced slip planes. So in that case, what will happen? Complete annihilation cannot occur, right? Complete annihilation cannot occur. So what will happen in that case? So there can be two possibilities. Either a row of vacancy will form, or an interstitial atom will be resulting. So if row of vacancy is forming, the orientation of dislocation will be in this fashion, and if an interstitial is going to form, then for an unlike dislocation, they will be of this fashion, right? So this signifies that a row of vacancy will be formed here, and an interstitial, then this extra half plane and extra half plane will give you that interstitial atom in the three-dimensional configuration, right? Coming to the problem which is given here, so if you closely look, there can be two cases, right? So case 1 and case 2. So in case 1, let's say we have two different slip planes, and on that the dislocation which are there of same sign. So same sign dislocation, but lying on the two different slip plane. In another case, let's say we have two slip plane and the dislocation which are there are of opposite sign. So this can be two cases. So when the attraction or the repulsion will happen, it is basically decided by the angle between these two dislocations. So let's say this is the theta which is forming between these theta angle between these two dislocations. So if this theta is less than 45 degree, right? If this theta is less than 45 degree for the same sign dislocation, then they will repel each other, right? They will repel each other. If theta is greater than 45 degree, then they will attract each other. Coming to the case where the dislocations are of opposite sign, then in that case, just opposite of this will be observed. If theta is less than 45 degree, then attraction will happen, and if theta is greater than 45 degree, then repulsion will be there between these two dislocations, right? Now what if theta is equal to 0 or theta equal to 45 degree? So in that case, the forces between dislocations are 0. Now theta is 0 is what? The dislocation are lying in this fashion in this case, and dislocation will be lying in this fashion for this case. So if they are at this position, then the case of equilibrium will be there. But yeah, in our case, like this situation is in the P and this situation is in the R. So in that case, what kind of equilibrium will be there? So if such arrangement is arising, then it is known as stable equilibrium, right? Stable equilibrium. And if such configuration is arising, then that will be unstable equilibrium. So why is it so? Because as we know, for an edge dislocation, this is our extra half plane, and just below it the plane is half of the plane is missing here. So due to such configuration, what will happen? The extra half plane presence will cause a compressive stress above the slip plane, and below it there will be a tensile stress developed in the three-dimensional space. So here if you see, if such configuration is arising, the compressive stress below this slip plane is getting compensated by this tensile stress above this slip plane. So compressive and tensile will make this equilibrium position stable. But in this case, here it is compressive and above this also compressive, so it will not be in stable equilibrium. They are in the equilibrium, but such configuration will be in unstable equilibrium. So equilibrium is due to what? The forces between dislocations are zero, but depending on the orientation of extra half plane, it will be decided whether they are in a stable equilibrium or unstable equilibrium. Now we'll answer this problem. So in the P case, it's a stable equilibrium. So for P, it's option 3 will be the right match. For Q, since they are of same sign and the angle between these two dislocations are greater than 45 degree, so they will basically attract each other, right? Theta is greater than 45 degree, that is 60 degree, they will attract each other. So for option Q, 2 will be the correct match. And for option R, they are in the equilibrium, but they are in the unstable equilibrium. So option 4 will be the correct. And for configuration S, they are of opposite sign, dislocation are of opposite sign, and the angle between them are greater than 45 degree. So in that case, repulsion will be happening. So they will repel each other. So option 1. So P3, Q2, R4, S1. So option A is the correct match for the configuration versus the nature of forces. So A is the correct answer for this problem. Thank you.